Okay, in this lecture we're going to talk about another application to quadratic equations, and it has to do with projectiles. Whenever we're shooting things into the air that are under the influence of gravity, we have a quadratic model, and we can model it with a quadratic equation. And the general quadratic equation for projectiles is actually given by S, where S is the height, is equal to negative 16t squared plus V0t plus S0. Now V0 is the initial velocity or speed, and S0 is the initial height. So in this case, right, the projectile is shot upwards from the ground, so its initial height is a 0. So in this case, S0 is equal to 0. So that's why you don't see it here. And the initial velocity is 73.5, so we have 73.5 for V0. And S is going to be the height. Now, above the ground, t seconds after projection. So we want to know how many seconds will the projectile be 100 meters above the ground. Now you'll see that this is a quadratic form, and we know that a quadratic has the form, a graph like this. Okay, so if I put some axes on here, we're looking at 100 meters, and of course we're looking, there will be two spots where that'll occur, right here and here. Alright, so we'd like to know what the values are of t are, and that's on this axis here, which is t. Alright, so above 100 meters above the ground, alright, means that we want S to be greater than 100. So what we have is negative 49t squared plus 73.5t is got to be greater than 100. Okay? Alright, so what we do is first of all we solve when negative 49t squared plus 73.5t minus 100 is equal to 0. Let's find where it's equal to 0 first. Alright, now of course this is a general quadratic standard form, so we have A here is equal to negative 4.9. B is equal to 73.5, and C is equal to a negative 100. Right, so using our quadratic formula for t now, it'll be negative b, which will be negative 73.5 plus or minus square root of 73.5 squared minus 4 times a times c, all over 2 times a, which is 2 times negative 4.9. Okay, so of course you're going to need to apply a calculator to this, and when you apply the calculator, be very careful the way you do it. Do this part first. Notice that we're going to have a negative. Alright, so we're going to have a negative by negative by negative, so this is still going to be negative 400 times 4.9, and we subtract that off of 73.5 squared, find the square root of it, and then it's going to be negative 73.5 plus or minus that value, all divided by negative 9.8 here. Alright, so we'll do that by calculator, and we end up with 1.5 1 and 13.49, rounding it off to 2 decimal places. Right, so to check, of course, now coming back to our picture here, it's not hard to see that, of course, at these positions here and here, alright, in between these two is going to be above 100 meters. Alright, now you can actually check that. Alright, and if we look at that, then we'll see that if you do a number line for t, alright, right here's 0, course, t equals 0 is where it starts. We don't have any negatives. So say 1.51, and let's suppose up here is 13.49. Okay, and let's see whereabouts this is going to occur. Okay, and we go and check. Remember, we're looking for when this s is greater than 0. So we're looking for where it's positive. So we might want to place 1 in here, for example. And when I put 1 in here, we're going to get it as negative. Okay, it's not hard to see. 1 squared is 1, so it's negative 4.9 plus 73.5, and then minus 100. So clearly it's going to be negative. And of course, if we put, say, something like 14 up here, all right, and we did it again, you'll find that this comes out to be negative here as well. If I put something like, say, 2 in here, right, if we put 2 in here, this will be 4. And if I put 2 in here, this will be 73.5 times 2, 140 something. And of course, when we do subtract the 100, so it's still going to be positive. And when we subtract just under 20, it's still going to be positive, so we end up with positive here. And so it's going to be above, so the projectile will be above 100 meters, above 100 meters from the ground, between 1.51 seconds and 13.49 seconds. Okay. All right, so that's how we do that. Okay, now that's part A. Right, part B says how long will it take for the projectile to return to ground. So at the ground, of course, we have S equals 0. So we're looking for when negative 4.9 t squared plus 73.5 t, right, is equal to 0. Now we can take out a factor of t here, or negative t even. So let's do this. So we get a 4.9 t minus 73.5 equals 0. So clearly this is going to be when t is equal to 0. That's when it started at the ground. It's going to be when 4.9 t minus 73.5 equals 0. So this will be implying that 4.9 t equals 73.5, or t equals 73.5 divided by 4.9. So we get our calculator to that, and we'll find that this comes out to be 15 seconds. So the projectile returns to the ground after 15 seconds. Notice we answer the question in terms of the question. And that's how we do a projectile motion question.